Thank you. All right. I prepared too many slides and I killed 5 minutes already. So I'll try to make it quick. So, cloud adoption at scale. My name is Santhosh. I work for Cognizant as a senior manager. I implement cloud technologies and a lot of work on the AI and ML as well. So we'll keep going. I'll try to skip some of the slides in the interest of time again. So why is it? What is it? Why it is important? So I've been developing cloud solutions for a while, almost like 5 6 years now. And over a period of time, we always want to get to the next level. We want to start implementing the AI technologies, edge computing, quantum computing. We have a lot of things in mind. We really wanted to do innovate, scale, and do a lot of things. But the reality, majority of the times, right, by the time we get to a stage, we'll not have enough funding, we'll not have enough things, etc., etc. Okay, so started talking about this topic for a while, almost a year, in my office, in my company, everywhere I go. Okay, the reason essentially, right, we wanted to really do a lot of good things and a lot of innovative activities at the same time, right? We want to implement the projects effectively. Okay, so I'll give some real world examples what we have done over like last 5 years, right? First first project we had like too many lessons learned. Second project we kind of shrink a little bit, but by the third one, right, we started kind of like implementing it much better way. So I just completed my fourth implementation about 3 months back. We scaled it to a level. It's kind of like a standard in a way, right? We have migrated the entire big data Hadoop to Databricks and AWS, and that saved us infrastructure cost of almost 8 million a year. And it's kind of like it's a big deal because like we are talking about huge data. I actually randomized like some of the numbers. I put asterisks, conditions apply kind of thing, because some of the numbers, right, I can adjusted not to kind of like disclose the exact number as such. So this is what we are talking about. So we have actually made a lot of savings, and about 15 plus terabytes. I made it as 10 terabytes data here. Okay, but we moved 10 petabytes of data, and we saw improvement. I'm talking about moving from big data Hadoop already. Okay, and I'm not talking about the legacy systems. Okay, we already have that environment fully optimized. On top of that, we can like made sure about 28% of additional performance improvement. The value proposition, I'll come to that later. This is kind of like why I'm getting into this, the weeds of it. Okay, so basically this is what we wanted to do. So I'll throw a question to probably every one of you. Hypothetically, right, let's say you get 20% of additional funding for your project, or you have a proposal that you will be optimizing the project to save a 20%. What do you want to really do? Where you want to spend that money in terms of technology? Go ahead. Say it again. More headcount. And in terms of technology, where you want to take it forward? Example, like you might be doing a cloud project. Okay, we want to do something else with extra money. Innovation. Yeah. Yeah, quantum. Yes, absolutely. Absolutely. So I'll give an example what we always think about it. Okay, so this will be very interesting. It could be like, like it might be eye opener as well. What is the excitement? Okay, the first thing what always happens is like, since I take care of the nitty gritty and the whole gamut of things in terms of starting from talking to the sponsors, program directors, everyone, right? So first thing we always go through is the project funding approval. It's kind of like a big deal. Before even get to the developer, right, we have to work in the behind the scenes, a lot of activity. So this is what we get to. Excuse me. So what we really want to build and design and build, etc. Okay, so this is what we want to build. This is where we want to start on the cloud technologies. And if we have more money, This is where I want to invest. This is where I want to kind of build more. If I still have more money, this is what I want to do. Okay. So this is our aspiration. This is what we really want to do. And this is the kind of like a challenge or real world scenario. What exactly that happens? We have the private funding done. So we have a bunch of cloud developers, cloud architects, all the chefs will come. They'll start coding. Okay. We do a lot of work. Alongside, we do a lot of things of this as well. Okay. So we have a lot of inefficiencies. How we actually kind of keep on uh, working while we are doing some migration. We'll go back to the inventory. We'll start looking at, hey, are we doing the right thing? So do we have the right design? We'll go back. Do we have the exact data governance process? Are we, how be it our access governance process? A lot of inefficiencies. On top of that, we always have this number of meetings that we wanted to get out of, and the number of reports that we want to kind of escape from. So I'm not saying all of the money is going there. So that's it's a representation. Out of the 100%, 20% is what going into the inefficiencies. 80% is still being spent on the cloud. So I'll tell you where exactly additional money and additional inefficiencies will go. So this is another example and use case. Okay, I just put together some numbers. I ran into the Databricks and AWS calculators. I took the Databricks website as an example to come up with some numbers. These are like pretty close to reality. This is what the cost look like for a 500 jobs. I'm looking at that 250 terabyte of data, and if you're looking at the incremental size, it's not too big again. So, but we are looking at a monthly cost of nearly 35,000 for Databricks instance cost, compute cost, and also all of this, and even for AWS, right, EC2. We use it a lot, but it's the most charged for service. Like nearly 40% of our bill comes from the EC2, but still, like the usage of it is barely to a certain extent. And this is the overall, like, monthly cost and yearly cost. I'm giving this rough numbers just to kind of like put it as a perspective. The size I took, the jobs, number of jobs, etc., right, way too small. And I work with clients where we actually do it like 20x, 30x of this number. So imagine where this is going. Of course, we'll have a lot of volume discount from the cloud providers, but still, it gets to a point. The top number, right? Of late, since 2 years, we are factoring in two things. Previously, when we were in on-prem, we always used to worry about the labor cost, which essentially we talked in that terms like how many developers we would need, how many instances we would need, etc. Now, since 2 years, we started talking about what is our labor cost, what is our non-labor cost. So technically, to paraphrase that, right? How many developers, data engineers, and staff we need, plus what is our cloud cost. That has become the norm. So in on-prem, we had the luxury of like running any number of queries. Everyone had access, and we never bothered anybody running the queries, running larger reports, running it multiple times. It was not a big deal for us. But since we are in cloud, now everywhere, right, we have to do the FinOps. We have to keep controlling in every piece, and every time we have to keep watching about it. So that has become a big deal. Okay, so why I'm talking about this? So like I said, I work for a corporation where we implement a lot of cloud technologies. Of course, I'm not representing my cognizant here, but I came in individual capacity, but still, like, that's me. Okay, and what I do, I do the cloud implementation, AI implementation, ML, and a lot of LLMs as well. So I do about like 20% of all the other great stuff, 80% on the cloud, predominantly doing the technical program management, solution architecture, etc., etc. So what we want to do as part of this, I want to give at least few takeaways. Let's fix this. Okay. We really want to go back to the previous slide and want to do those cool stuff of AI, the cool stuff on the edge computing, the like doing the real time streaming, etc., etc. And we want to kind of like do it within the available budget, available funding, etc. So let's see. Okay, so there's some areas, right? So probably these are some of the key takeaways we can actually look at. We can actually do the look at the key strategies, how we can actually migrate it efficiently, because most of the cloud adoption is starts with migration. Okay, then we'll actually look at what are the better ways of like optimization, and what are the better ways of like value creation, etc. So these are some of the key takeaways we'll see. So in terms of the product roadmap and product journey, right? So these are the first two areas I want to kind of focus on. This is where the crux of the topic. In a way, the discovery phase and the design phase is what, if we do this correct, if we do it perfectly, this will actually lead the project to be done in a greatest efficient way. Okay, because all the time I see, once we are into the actual coding, actual development phase, we'll go back and start looking at the discovery phase items. We'll be assessing the inventory. Do we really need to migrate this table? Do we really need to do this in this way, etc., etc.? And if once we do the right designs, right policies, right access governance, etc., once we establish all of this, the second two steps will be cakewalk. Pretty much like, I mean, they will be pretty much on the development side and consumption and optimize. In fact, I mean, I really want to replace this optimize with innovate. Okay, that's where we can actually get to. So how do we do this? So from here onwards, it's to like too much of nitty gritty, but I'll try to make it as simple as possible. Okay. So what we are looking at is like the very first step of the assessment, or the discovery phase. So here, right, we'll go through all the inventory available. We'll take a look at it. What are the applications that we have, and what are the activities that we need to perform? What is our framework, etc., etc. And we already have a predefined security and governance process, all the stakeholders, etc. And when once we get into the design phase of it, right, we carry all the available inventory, we'll take it forward, we'll look at all the inventory, ready inventory, we'll look at what is our strategy in terms of designing. Are we going to do the lift and shift? Are we replatforming, re-architecting, or doing something about changing the entire landscape of it? We'll make everything ready in terms of our inventory. Then, of course, we'll actually cascade all of our existing security and governance. We'll improvise them. We'll list out all the policies. By these two phases, we'll be pretty much done with the majority of the landscape of the project, program, entire piece. Okay. So the next two steps, they're going to be pretty easy, because this is where like the entire development piece comes into picture. So we have the curated inventory already. Now what we need to do is simply we need to start using them and start converting. So couple of interesting topics, right? What we want to focus is like we have a lot of accelerators available. Google provides accelerators, and a few other providers provide accelerators, and we have a lot of open source. We can convert majority of the code using these accelerators, convert the legacy systems from legacy ETL or legacy existing systems to Python code or a PySpark code, or like to even PL/SQL. We can do a lot of conversion there, and we have a lot of accelerators available in terms of the data validation. Those accelerators will help us directly generate all of the test cases, and also we can take it forward very efficiently rather than like spend too much time worrying about how I'm gonna do it. A lot of accelerators will help us bulk convert the code. Since we already have the inventory information, since we have the assessment of everything, and we know what is the strategy, if we are ready to take all of this table, all of these data, or like some of this data, etc., because not everything fits the same size. Some of the tables, right, they don't need to be in the cloud. They can directly go into the storage, or like maybe the long-term storage like archives, glaciers, etc., because they are pretty much more of like compliance data, or like 7 years legal data, etc. They don't need to be transferred through ingestion process, etc. Once we get to this, right, the last steps essentially, right, so either optimize or innovate or consume. Okay, so this is where we'll get to. So most of our data, right, so we can actually do a lot of orchestration. In this way we can optimize this to an extent which is really really efficient in a way, right? A lot of jobs, they don't need to be running on hourly basis unless they really have a business need, unless they have a real time scenarios. And a lot of jobs, they don't need to be running on real time streaming all this. We need to kind of categorize what is really relevant, etc., and based on that we can run a lot of scheduling techniques. Okay, so I'll get to the next level. Just to kind of like keep it very simple, right? In a broad way, we see the optimization in two ways: one, a strategic one and a tactical one. A strategic one, right, we look at the 10% or 20% is what we could actually achieve with simple seamless innovation using a lot of available AWS, GCP, Azure commands, etc. And when we are looking at the revolutionary one, right, we can actually look at re-platforming, re-architecting, and changing the CPUs to GPUs, etc. And the third one, essentially in the strategic, right, we can actually adapt the smart systems. We can use AI and the ML powered lot of tools. Expensive, but yeah, that's kind of like, I mean, one of the option. Tactical, this all can be done very easy. Tactical, we can go and implement them today. So probably with this session, right, probably you might be able to do most of this very quickly and do it. So the execution part of it, I'll keep it simple. So these are the areas we can actually simply go and do it today, right now. So the compute policies, the cluster policies, and the scheduling, all of these great things. These are the ones which will actually save a lot of time, a lot of money in terms of how we optimize our areas. This can be done very quickly and efficiently today. We don't have to wait for expensive AI tools to come and do it. However, right, I mean, there are a lot of things. Okay, so I just took an example, AWS example, just to kind of quote what are the easy kills that we have available. Okay, we have the compute, we have the cluster policies, etc. So some of this, right, I did not intentionally put icons because I actually see too many icons. I get lost of like how many icons I see every time. Okay, so some of the compute, right? So we all know this how we can actually do it, but I picked and chosen ones, some of the curated ones. Okay, not every, I don't want to go after every kind of AWS available service, but some of the instances, right, spot instances, I know like some of you use it a lot because we always pick and choose non-peak hours to pick the spot instance to make the cost very efficient. We always do that. We do a lot of auto scaling, compute optimizer. In fact, I mean, like I added a couple of the predictable ones as well, including the sustainability for the compute pillar and also the ML services for the clusters and also the data sync for the predictive ones. Okay, so here again, I actually like, gave a lot more examples for each of the area. Okay, compute, cluster policy, storage, visibility. Just to look at the color coding, right? The blue ones are pretty much available. You don't have to pay a lot, and the green ones are like AI and ML powered. They they will actually make your compute go a lot faster. Okay, so this too much to grasp. Anyway, I'll make these slides available on my LinkedIn somewhere, so you can actually grab all of this good stuff. And we do have a lot of tactical execution, a lot of things that are going in. We can actually do all of it without spending additional time because these are already available in your cloud. If you're adapting the AWS or GCP or Azure, you might already have most of this available. So you can actually do all of this optimization very easily and efficiently. Okay, so what we are going to achieve all of this? Simple. I mean, like, so these are the 4 areas that we are going to achieve, especially the user experience, which is the most predominant one. Then, of course, we'll get the governance part, we'll get the incremental business part, rapid innovation. The top one is what my primary focus area, because anyway, we're going to achieve all of this. I really want to get to the last one with all of this optimization and building efficient systems, right? We will have enough time, money, and the performance on the system that will actually enable us on the rapid innovation. We can do a lot of accelerated AI ML integrations. That is very, very important. And we can actually make all of our cloud interconnected, and we can actually make it more useful for the open sources, etc. So I'll get back to the case study very quickly again. Not much change. When we have implemented this, we almost save like about $8 million a year by cutting down all of the infrastructures, all of the licenses, etc., etc. That's a huge deal. And previously, I used the asterisk. The asterisk I use is essentially right. If you do it right, we'll save it. If you don't use it right, we'll start burning through very quickly. And that's again, I gave that example. So here, right, if we implement this efficiently, we might be able to do it much lesser than the $50,000 cost monthly basis, and much lesser than the 35,000, or much less than 85. So ultimately, right, all of this saved money can be used for our next activities. In terms of call of action, right? I'll keep it simple. So this is our picture. This is where we wanted to be, and this is our situation previously, and what we can do essentially, right? One actions or at least four actions. Let's do the effective migration or effective adoption. That's one very key area. Let's do a very good assessment of our existing cloud, what we have already implemented. That also can be done. It's never too late. We can go back and fix. We can run an audit report. We can actually fix most of the inefficiencies. That's one area we can do. And we can actually do a lot of proven optimization. Some of them are actually provided in this slide, and I attached a lot of spreadsheets as well. This also we can do. Okay. And last not but the least, when we move from on-prem to cloud, it's a big culture shift. Some old school technology users, they'll keep running their queries for no reason. They'll execute at the peak hours, costing us too much money. So we need to kind of train them, skill them, reskill them to get to a point to use it efficiently. Okay. So bottom line, right? So we have the funding. So what we want to accomplish, we really want to keep doing that. And in addition to that, I just want to kind of like get rid of the fire pit. I want to do this. And bottom line, right? This is what I want to kind of like get to the 20% of the money going in with our efficiencies. Okay. I really want to spend time on AI, really want to do all the streaming analytics through my Spark, everything. And I really want to innovate. And we'll get to that by using all of this. Okay. So for unicorn. So we cannot make our companies unicorn sometimes, certainly, but we can actually make our project as a unicorn. We can actually make our project as unicorn, and one such project everyone can actually strive to follow. Okay. So thank you so much.